Okay, let's try to look at the matrix multiplication. In matrix multiplication, the focus here is to multiply row versus column. The row of the first matrix we multiply with the column of the second matrix. But when we are doing this, we consider the size of the matrices. So when we try to multiply matrix, we try to see that the columns of the first matrix has to be equal to the rows of the second matrix. Let's look at the example which we have here. Let's try to have a solution, but before we calculate, we'll try to figure out what I'm trying to say. So have A, B. Where there is A, we'll put the matrix which we have there, which is 2, 3, 4, then 2. Then we have B, which is -1, 4, 6, and 7. So what I'm trying to say here is, when you want to try to multiply these matrices, you make sure that the number of columns of the first matrix which we have is this one. This is the first matrix, and the second one is this one. So when we want to multiply, we make sure that the columns of the first matrix has to be equal to the number of rows of the second matrix. Now, what are these columns? The columns are these vertical numbers which we have. For example, here we have 2 and 4, this one. Here we have 3 and 2. These are the columns. So we have 2 columns. They have to be equal to the number of columns of the second matrix. So the rows of the second matrix, this is 1, then this is 2, 1 and 2. So you see, we have 2 columns in the first matrix are equivalent to 2 rows of the second matrix. So it simply means multiplication will happen here. We'll be able to multiply. If they are different, we cannot be able to multiply. So let's try to multiply. Like I said, when we are multiplying, we'll be taking row versus column. We'll be taking row versus column. So let's try to multiply. Row versus column. But for multiplication to happen, like I said, the number of columns of the first matrix has to be equal to the number of rows of the second matrix. Okay, so let's go. If you have this one, the second step which we are going to have, we are going to take the row of the first matrix, which is 2 and 3. We'll multiply with the first column. Afterwards, we'll multiply with the second column. So let's try it. We have 2 multiplied by -1, so it will be 2 multiplied by -1. After multiplying 2 and -1, we add. Then it will be 3 multiplied by 6. It means in that way we are done. We'll take the same row of the first matrix, we multiply with the second column of the second matrix. So it will be 2 multiplied by 4 plus 3 multiplied by 7. So we put it in a square brackets. After we are done like this one with the first matrix, with the first part of multiplication, we also go to the second row, which is this one. We also multiply with the same columns of the second matrix. So it will be 4 multiplied by 1, so it will be 4 multiplied by -1, 2 multiplied by 6, plus 2 multiplied by 6. Then it will be 4 times 4, plus we have 2 times 7. 2 times 7. It's not clear here. Let's write it again. So we are going to have 2 multiplied by 7 at the end. 2 multiplied by 7 We haven't chosen a good color here, so let's try to take another color which we'll be able to see. Okay, so in this case, let's try to simplify it. So it will be 2 times 1, it will be negative 2. 3 times 6, which will give us 18. 2 times 4 will give us 8. Will give us 8. So it will be 8 plus 3 times 7, which is 21. Then we have 4 times negative 1, so it will be negative 4. Then plus 2 times 6, which is 12. 4 times 4, which is 16. Then we have plus 2 times 7, which is 14. So let's try to find the final answer here. So our final answer here, it will be negative 2 plus 18, which will give us 16. Then we have 8 plus 21, which will give us 29. Then negative 4 plus 12. Let's write the answer immediately here. So we'll have 8. 16 plus 14 will give us 30. So you see, we are just taking a row multiplying with the 2 columns of the second matrix. After that, we take the second row of the first matrix, we also multiply with the 2 columns of the second matrix. Most importantly, for multiplication to happen in matrix, the number of columns of the first matrix has to be equal to the number of rows of the second matrix. So for now, let's stop here. We'll try to work out another example in the next lesson, but for now, let's stop here.